next speaker, Professor Prasanta Kumar Ghosh. He is an associate professor in the Department of Electrical Engineering at IISc Bangalore. He was a research intern at Microsoft Research India, Bangalore, in the area of audio-visual speaker verification from March to July 2006. During 2011 and 2012, he was with IBM India Research Lab as a researcher. He received the Best MSc Thesis Award for the year 2006-2007 in the Electrical Sciences Division at IISc. Also at IISc, he received Professor Priti Shankar Teaching Award for Assistant Professor 2017 and Pratiksha Trust Young Investigator Award for 2017. He is an associate editor of Computer Speech and Language elsewhere. His research interests include non-linear signal processing methods for speech and audio, speech production and its relation to speech perception, silent speech processing, and automatic speech recognition with applications in education and healthcare. Sir, I would request you to address the gathering. Over to you, sir.
Thank you very much. Just to make sure, do you see and also hear me well?
Yeah.
Yes, sir.
I can see you well and you're loud and clear.
Okay, so let me just share my screen. Do you see the screen now? I'll just make it full screen. Do you see the full screen of the slide?
Yeah, very, very clear.
Okay, perfect. So thank you, first of all, for the kind introduction, and thank you for inviting me here for the talk. And very nice arrangement. And I first of all like the very last question, because that to the last speaker, because that nicely connects to this presentation. So as you see, the title of this presentation is the impact of training data design, right? On one second, let me just move this out of the box. Yeah, the impact of the training data design on the performance of ASR and TTS systems. So what I'm going to do in this presentation is I look at the performance of these systems from a different angle altogether. Most of the time, the performance is tied to the complex model and better modeling, right, with more complex networks. But as in this talk, you'll see that there has been few works very recently, which is asking this question, that these models that are being coming up, they are being trained on some data. How this data that is really providing the right information to this model can impact the performance of the systems, right? So that's the context. So before I go on, I'd like to tell you where I come from. Currently, I'm part of the SPIRE Lab. I head the SPIRE Lab at IISc. It's a fantastic campus. Just to tell two slides about the lab. So we are in the green campus of IISc in the Department of Electrical Engineering, and we work in a variety of research problem with a very vibrant team. In particular, these research problems span from basic signal processing to statistical learning, machine learning, and a variety of applications, but they primarily lie in the domain of healthcare and language learning. And as a part of this research initiative within speech and audio, we have several thematic research directions. One is speech production, another is audiovisual speech processing, the other is of course speech recognition and synthesis, because they go and gel well with those applications. So if you're interested, always drop an email to know more about the activities in the lab. With that, now let's go deep dive into this title, right? So I want to just make sure that we all understand the title well, and then I'll tell you what scope we're going to talk about in this presentation. So first, I'd like to tell you what are ASR and TTS systems. You already know, but still I'd like to reiterate. So an ASR system, which is automatic speech recognition, also called often speech to text, STT systems. If you think this to be a black box, it takes a raw audio signal as input or a audio file as an input, and outputs a text file or a transcription of text. Okay. On the other hand, give me 1 second. Yeah. On the other hand, for the text-to-speech synthesis system, the input is a text or a text file containing a bunch of words and sentences, and the output is raw, right? That is known. But now, before I tell you more about how the training data impacts the performance, let's understand what is performance of such a system, right? So let's go one by one. The first one is the ASR system. So the performance of an ASR system is determined by what is known as word error rate. Let me be very precise here. What is word error rate? Here is a quick definition of word error rate. If you do not know, if you know, that's great. So essentially, when you have a target, right, that's what you expect the ASR system to predict. For example, in this case, the cat sat on the hat, but the prediction might have been the cat sat on the mat, right? So there are various kinds of error that happen. One is called insertion, meaning there was no word, but you actually inserted a word, which didn't happen here. And it's called deletion. There was a word, but the prediction missed it out, so it got deleted. Substitution, it means that there was a word in the target, but that got substituted with another word. For example, in this case, had got substituted with mat. And then the total number of words, which is 6 in the target sentence. So, and then the formula that you use to compute the word error rate is exactly this. So it will be insertion plus deletion plus substitution over the number of words in the target sentence. And that multiplied by 100, that will be the WER. So another example will show that how the WER can really shoot up and become 100%. It can be more than 100% in cases where you make a lot of mistakes, right? So in a nutshell, we want the WER to be lower as much as possible, and that's better for the performance of the ASR system. So on the other hand, for the text-to-speech system, mean opinion score is the performance metric. Looking at how this mean opinion score all started from ITUT, which had a variety of aspects to decide on the score for the for a audio signal or speech recording. So it can start with an overall impression, which asks how do you rate quality of the sound, what you have just heard, or how much listening effort that you have to give, that you have to give. It could be the pronunciation. Did you notice any anomalies in the pronunciation? It is about speaking rate, whether the rate of speaking was good or normal, voice pleasantness, comprehension problem, articulation. So there are a whole lot of aspects that goes in judging how good is the quality of the synthesized speech from a TTS. In fact, for any speech. So MOS is used even in other ways, also not necessary for TTS. But to summarize, you can say, well, if I give you audio file, can we put a rating starting with excellent, which is rating 5, all the way to bad, which is 1, right? So it means that when we want the rating, the MOS score, to be as high as possible to call a TTS system performing very well. So now I hope that you are clear what you're talking about, performance of system, right? So slowly decoding the title. Now, the rest of the title. How does the training data design impact? Right? So let's understand it very well that when we build such a system, it's a program essentially. Either TTS or an ASR is a program. The parameters of that program is determined using some data. And what do we mean by data? By data, I mean in the case of ASR, it will be parallel speech recording and the text, because that's what we need to train the system to tell if this is your input audio, this is the text, and the system should be learning from this. Right? So we need a lot of such training data to train the system, and for TTS the other way around. Right? So certainly we need the training data. But now the next question is, when we evaluate the performance of these systems using WER or MOS, of course we don't evaluate it on the same training data. We'll be evaluating on something what is called a held out test data set. And sometimes you do not know what is the test data set, right? If you know the test data set, it is often easy to create a training data set which is matched to that. And if you do not know, that can be the case many times, then you may have to take various steps, right? Such as data augmentation, adaptation, and many other things. We'll talk about them briefly soon. So important thing to remember here is that the performance is evaluated on an unseen set, which is called test set. So now the question is, when we do not know what is a test set all the time, how do you design a training set which will work best in all test scenarios? Is that possible even? Answer is no, not. You can't have a training data which will train a system like ASR and TTS, which will work really great in all the scenarios. Right? So with that background, I just want to give a simple structure for this presentation. So we'll have three essentially topics to discuss. So first we'll talk about the corpora for ASR, what exists, what are the challenges, what design aspect you should look at. Similarly, corpora for TTS. And then we'll tell you what are some of the recent initiatives in corpora creation that has been happening in India with this. And all these questions that you're asking will come there. Right? So let's start with the corpora for ASR. So this is your ASR system. And this ASR system could be categorized based on various parameters. So the vocabulary size could be small or large or unlimited in a theoretical sense, meaning this ASR system should be able to handle certain set of words, right? If this ASR system is not informed or trained with a very complex or unknown word, it will not be able to recognize that. So those set of words is called the vocabulary. So it could be a small set of vocabulary. It could be, let's say, you can think of a banking system, right? There it will typically be few digits or few phrases or terms associated to banking. That will be a small task. But when you want to recognize anything spoken by an user, then that will become an unlimited or large vocabulary speech recognition. Similarly, speech type, it could be that we want to recognize isolated words, like it's an IVR system, you want to respond yes, no kind of questions, or a simple phrase. Or on the other side, it's a continuous speech that you want to recognize running natural sentences, a running speech. Then the speaker dependent. You want to make an ASR system to be speaker specific or speaker independent. You want this to work only on a single speaker or any speaker that speaks. So each of these will bring challenges and associated technicalities to develop such systems and the training data. And finally, the grammar. For example, there are some strict syntax. For example, if we talk about the banking itself, right? You don't speak in banking anything arbitrary. You'll say, okay, transfer this amount to somebody. Or I'd like to set up a fixed deposit, right? There are certain kind of sentences you speak. There's some certain grammatical structure. You don't really speak something about some tree or something about the weather condition, right? On the other side, the difficult task will be for the grammar, it will be natural language. You want to speak anything in any structure. It could be even not grammatically correct sometimes, right? Because when you speak in a conversation, it is not always correct. So what we'll do is in this presentation, we'll stick to the difficult task, meaning we'll talk about a large vocabulary, continuous speech, as if in natural language and speaker independent ASR system. And we'll see for that, what kind of training data is needed. Now, note one thing that for the easy task, the training data design and requirement will be different. But we'll be mostly talking about the training data design for the difficult task. So when it comes to difficult tasks, as you understand that anybody, in fact, can speak anything in any way, and we want that to be recognized. Quite challenging. So we have to really think about doing that very well, the design of the training data. And when you design such training data, it could be a function of the ASR model itself that you're using. So if the ASR model is complex, the amount of data you may need may be high. Or if the ASR model can handle some of the aspects. For example, it is robust to, let's say, the noise variation of certain type. or it is robust to speaker variation of certain type because the model itself takes care of those normalizations, then you don't have to provide that much of data. So there are this depends on the model also. But if you don't really design the trained data well, something like this can happen. And this is a very well-known video. I'm sure many of you have seen this. This is a video where a person is trying to use Alexa, and you'll see how Alexa is failing to recognize a simple word or a phrase. So let me just play and tell me whether you can hear it. If not, I'll have to play it again. Oops. Not sure. Sorry about that. See, yeah.
What is Alexa? Alexa, what is famous person?
Sorry, I don't know that.
Alexa, famous. Famous.
Right. So here, what's happening is that the famous person, or do you know what is famous person? Alexa was finding it difficult to recognize. And this is a well-known video. As I said, you can always YouTube it and find it out. As it turns out, the lead for the Alexa in Amazon was telling me that this thing happened because there was a wrong choice of the model. By that I mean, this person was sitting in US, and he's an Indian, so his accent is Indian, right? But because he's in US, the Alexa model that was being used is trained on the US speakers, not the Indian speakers. So it was finding it difficult. Can it be this much? Yes, it can be this much, right? So the variation in accent or dialect, right, can cause a system to perform. So you could see what is the WER here. You can easily do a simple math. So it is not just the dialect and accent. It could be because of many other reasons. It could be because of the training test mismatch of the acoustic condition, for example, right? It might have been trained on certain kind of acoustic scenario, but you're testing in a kitchen, or it could be you're testing in the roadside. It may not work well there. It could be age and gender of the person. So we typically expect that the training data will cover all age population, right? Or both the genders. It could be literacy level. The way a Hindi speaker from Delhi will speak, it will be different if you take a farmer from Bihar and they speak Hindi, right? The same sentence or the same way. The tone, accent and intonation, all of that will change. So I'm talking about all of this assuming, let me repeat this, there is no OVs, meaning there is no out of vocabulary word. See, the word that this person spoke was famous person. These are very simple words. It's not some crazy unknown words, right? So these words, although is in the knowledge of the computer, still it is failing. So that's primarily because of the acoustic and the dialects. Okay, so does that then mean that for every test condition, we need to go out and obtain training data to match with the test condition? And that we can't really, cover that up because there are so many test conditions. How can we even take each and individual one? So we have to really have all pairs of test and train sets of the world. That's not really possible. Of course, the answer is not really, right? There is what is called data augmentation schemes. So, for example, if you want to take care of the noisy test conditions, you can do data augmentation with additive or convoluted noise. If it is a reverb room, a reverberant room where the ASR has to work, then you can add reverberant effect in the training data so that your training data is rich enough with the reverberation so that the computer is trained with that. Then you can do pitch scaling to simulate people of varying pitch, or time scaling to simulate of different speaking rates, so on and so forth. Right? So you can create these varieties of data augmentation given a speech recording so that it can cater to those variabilities. But having said that, it doesn't cover everything. For example, we do not know how to even create a different dialect of the same language. For example, Hindi, there are so many dialects. So if I give you the same sentence spoken by a speaker from Delhi, as I said, metro cities versus village, we don't know how to synthesize that. And these are big questions that people are working even today. For example, age. Can you really create how an old person will speak the same sentence from a given, let's say, person of 20 to 30 years, right? And also literacy level. Depending on the literacy level, you speak in different ways, give different kind of pauses, various factors goes in. So all aspects are not feasible. So that's why we have to have a two sort of parallel threads in this to solve this problem. One is we collect training data, which will cover, or which will take care of aspects which data augmentation cannot take care of. So that will be the approach. But if you have to do data augmentation, even if we have training data to handle those cases which data augmentation cannot, we need to start with some corpus, right? So the question is, do we have at all corpus? So suppose one of you wants to build an ASR system, let's say, to suppose you're a writer, right? And you want to build an ASR system. When you speak, suppose you write about economics. When you speak something about economics, it automatically types that. And that's a great application of ASR, automatic transcribing. So if you have to do that, the question is, what corpus will you use to train your system? Or even if you have engineers, what corpus will you give them? I mean, first of all, you have to know what all are available there first. And then we can decide whether those are useful, and then see whether you have to really record a new corpus or a training data, correct? So let us see what all exists today. In fact, there is a lot of corpus that exists today, but majority of them are in English, right? So here it shows English corpora across the world, and the ones that are in red, they are publicly available, freely available. You can download them. So the way I have written here is the name of the corpus in bracket the number of hours, so that you can get how big is the corpus. So you can see there is a variety of them that are there in the market. So the ones in black, they are typically those are the ones where you have to pay and get, and they're expensive. So the largest corpus, if you see carefully, is this Fisher, which is a paid corpus, 2,000 hours, and it's pretty huge. So, and among the freely available ones, literary speech is the largest corpus. There are a few Indian English corpus also, and I've listed a few of them. It may not have covered everything, but these are the big ones. Of course, there's one NPTEL, Indictimate from our lab, then IIT Madras corpus, and then Indian language corpus for speech recognition. And then there are a whole lot of Indian language corpus in different Indian languages. It starts with, again, the similar kind of format I have written is the language, so the corpus name, how many languages in that corpus, and what is the number of hours. So there are corpus from LDC IL, then TDIL, NPTEL, then you have, Telugu, Naturalistic Emotion from IIIT Hyderabad. You have from Common Voice, Mozilla, then you have Microsoft released as a part of InterSpeech Challenge in 2018. And then Man Ki Baat, you have quite a few. And then from CMU, there are Gram Bunny. From ELRA, you get quite a few. Then you have LibriVox audiobook. You have Hindi ASR Challenge dataset. And recently, we are having a Marks ASR Challenge that also have released dataset. So these are all, spread apart in various forms. Not all of them in the same place, and some of them you may get easily, some of them will be difficult to get, and varieties of them. So in terms of accessing those corpus, you may have varying degrees of difficulties. But they exist, right? And there are a lot of efforts going on today to collect more corpus. So you see, we knew that the train test mismatch can cause problems. And if your goal is to develop an auto transcriber for you in Telugu, for example, you are searching for corpus. Is there a corpus that I can build up? And you see, okay, yeah, maybe this Microsoft has 50 hours of Telugu. The question is, will that be good for me? Because it was recorded by somebody with some certain conditions. You have to understand, experiment, and investigate those before you can expect that it will work on your voice, right? No problem. So that's the first thing. But now suppose, if we take this entire set of corpus and try to see what are the major categories, it will be primarily two. One is read speech, and another is spontaneous speech. So read speech will be typically excerpt from books or news broadcast or list of words that you read or number sequence. On the other hand, the spontaneous speech will be dialogues and meetings. In a meeting, you speak spontaneously, and then narratives, you narrate some stories or any other lectures or conversations when you are conversing with somebody. So now, so far so good, right? So we understood that there could be challenges if there's a mismatch in train and test. And if you have a target test scenario that you want to use your ASR on, you go out and you know what is out there, you can search for it. But suppose you don't get what you're looking for, you don't have a matched condition. For example, if we have to build an application for farmers, where poor farmers, let's say, right? Not all farmers are rich. Poor farmers who speak in their own native accent way of asking questions. What is the price of this fertilizer? How will be the weather tomorrow? Should I, harvest this crop this season? Various questions. So suppose we want to build an application which can listen to them and then convert them to text and send it to some center who can respond back. Suppose we want to develop such thing. Question is, do we have such a corpus, or do we have a corpus at all? Let's say we want to do it even in Hindi. Do you have a corpus in Hindi that can do it? And unfortunately, that's not the case. You'll see later in this presentation that we have a project to really come up with such a resource that can take care of those kind of applications. So when you have to go for collecting a new corpus, what all you have to pay attention to? So there are many ways many ways you can collect new corpus. So I'll talk about only two here. So first one is called recording of predetermined sentences. Meaning you go ahead and determine a set of sentences and you want a bunch of people to speak, right? And that's how we create a corpus. So it could be, let's say, so to create such a corpus, there are three major stages. So one is you create the number and the type of sentences. So to determine what are the sentences that we have to prepare for somebody to speak. The second will be you have to select the speakers, right? And then finally, we have to take this sentence to those speakers and they'll speak. Right? And of course, we have to make sure that they don't really speak in a widely different acoustic condition, right? Moderately similar ones. Now, there are several points to remember and aspects to remember in each of these. So if we have to determine the number and type of sentence, both are open questions. Then how many sentences we will determine? What are the types of them? What vocabulary they will cover, right? Do we need to really ensure some set of words to ensure phonetic richness, meaning the sound structure? So you don't want to create a set of words which doesn't have some sound, right? We need to make sure that all sounds are present in this. And then for that, we need the graphing to phoneme converter for understanding those phonetic, modeling those or knowing those phonetic listeners. Then the second is speaker selection. How many speakers will you select from or record from? What will be their dialects, age, given a particular language that you want to cover or a region you want to cover? And then, of course, any data collection will not be free. You have to. It comes from you have to pay the people who are speaking, otherwise you don't get a good quality data. So you have a budget, I'm sure, right? Once you plan to collect some recording, and then you have to pay individual ones. So you know how many people you can reach out to also is a function of your budget. And third, speech recording itself, right? Question is how much you want each person to speak or each speaker to speak. How many sentences you want that person to speak. How to determine which sentence a person will speak, right? There's so many whole lot of questions. And then, of course, finally, how you record is also a question. Will you record with a variety of devices or a single device? And how does that impact? What will be the sampling rate, bits per sample, all of that. For example, we are trying a few days back a model by that is freely available from Vakyant's team, and we are giving 8-bit instead of 16-bit audio files. And it turned out that it was performing terribly, although we could hear everything normally. And we found out that there was a mismatch in the bits per sample, which we didn't realize, because the recording device in this test scenario was doing 8 bits per sample, but which was not the model Vakyant's was trained on. Okay, so I'd like to now tell you how critical are all of these. And for that, I will refer you to this paper, which is one of the paid large corpus called Wall Street Journal, available from LDC. They have a document which tells how did they took care of all aspects while they collected this corpus. Right? So I want to highlight one part from that paper. For example, there are various stages even for selecting the text that was supposed to be recorded. It was first filtered for readability, right? You can't give some text which is not even readable. Somebody will find it difficult to even read out. Then you have to make sure that the word that you are choosing has certain familiarity level. If I give you a crazy word, right, from some medical term or someplace, you won't be able to, you'll falter to speak. You have to think about the subject that will be recorded. Then there's the quality filtering that is done, and also to make sure that this filtering that is done, it is done for the recorded text or also the text that will be used for language model. So there are various such considerations that you have to make while preparing the text itself. Then I'd like to point out a few other works that will tell you how critical it is to design sentences. When in particular you're going to record a new corpus. So this paper talks about deriving sentences, rather selecting sentences, which are phonetically rich based on particularly triphones. So triphones are, if you know, is a collection of 3 phones which comes in a sequence. For example, if I say, I want that book. So in book, word book, there are 3 phones, right? Ba, U, and Ka. So that's a triphone. But this U can come in another context. For example, root, right? If I say root, there'll be R, O, and T, right? So this O sound in the context of book will be different than in the context of root. So the question is, are we really covering various sounds in various contexts? Can we design sentences to make sure that happens? And this paper talks about that. And this is not the only paper, by the way. If you go and do a quick search, you'll find many more. And I'd like to highlight a few to give an impression here to you that collecting corpus for building ASR or TTS system goes through such planning and execution, which is not always easy. So in this case, they are developing a Tibetan corpus, and you see they first collected a text corpus of 100,000 sentences. And then based on this triphone juncture and many other factors, they select a subset of them, right? As you see underlined parts. And then they went ahead with. So as you understand that there was a lot of effort went in selecting these sentences itself. Similarly, this is another paper where it is for Latvian speech recognition corpus. I'll not go into the details because that will be repetitive. In fact, people have done a similar job when they want to collect or create corpus from web. So there are a lot of data in the web from YouTube and many other places. When you want to pull all of them and create such a corpus, we have to make sure that they are phonetically balanced as well. So phonetic balance or richness is an important factor so that you know that your model is well informed for all varieties of sounds in various contexts. So it becomes even more interesting when it's a code mix, right? When you have a language where like Hindi English, right? When you mix Hindi as well as English in a sentence, you have to determine a similar kind of phonetic balance. And it's not easy because the grapheme to phoneme for English and Hindi need not be equally easy to develop. For English, it will be of different type than Hindi because Hindi is more one-to-one in terms of grapheme to phoneme, which is not the case for English. Again, the same concern was raised for phonetic balance here. Right? Same for Arabic language. So the same theme comes up in many of these corpus design. That's what is the impression I want to give you here, and so that you are aware of it, right? So when you go and collect a corpus or use a corpus, you now first go and ask, is this corpus really something that satisfies this criteria, right? Somebody might have just collected based on something, but how do you guarantee that those are indeed phonetically balanced? So that's, and you see all these papers that I talked about are mostly focusing on the number and type of sentences. But how do you select speakers? That is not almost discussed in the literature. Same, paying attention to the speech recording. So those are sometimes untold stories. Unless you be careful and pay attention to, you will lose the quality. For low resource languages in particular, where you can't collect a lot of data, but typically you do adaptation. For example, if you want to develop, let's say, something in Magahi, which is a variant of Hindi, then you say, well, I have a lot of Hindi data, but can you collect a little bit of Magahi data? So now it becomes even more challenging to ask, okay, what will be the Magahi small data set? What are the sentences in Magahi such that is the best for doing the adaptation, where you have already some Hindi corpus, right? So that adds one more layer of question, and you have to determine the sentences based on that. On the other side, apart from recording of determined sentences, there have been a lot of effort is also going on in transcribing of pre-recorded speech. So, for example, you may have an audiobook available, but their subtitle or their transcription may be noisy. How do you do a good job of transcribing the pre-recorded speech so that you collect automatically a lot of corpus, so that you don't have to go out and have the hassle of recording from people, right? So that's the advantage of this approach. So, in fact, again, people have been working on selecting data for ASR when you go and mine from the web or mine from existing large amount of pre-recorded speech. This paper in particular is a very interesting one from Microsoft. They talk about, to be very careful in using an ASR to transcribe. For example, in this case of Magahi, it may sound like it's a variant of Hindi, so we have an Hindi ASR. Why don't we use that? And they show that there is a particular transcription bias that comes if you do that. So they propose a way to avoid that. I'm not going to go into the details, but this is just to tell you that you see so much effort and work and research is going on in taking care of the quality of the training data. And now for a particular test scenario or domain that you want to use this ASR for, what all you have to pay attention to. But even after all of this, question remains. So, for example, in Indian context in particular, right? Suppose I want to record or build a corpus in Marathi. There are so many variations of Marathi, right? If you go from one part of Maharashtra to another, there is so much of dialectical variation. Which part will you record from? How many speakers will you record from? And in which dialect? How do you determine the dialect? This is a continuum. You can't really tell these are the discrete dialects. There are a lot of changes happening. Right? Question is now, with the same sentence, hold good for all dialects? Because depending on dialect, there are changes in the sentence itself, the word itself. Right? And then, of course, how do you select speakers? And then again comes how do you determine how many sentences each speaker will speak and how many of them they'll speak? How many repetitions will you have? So suppose take a sentence, do you want this to be repeated by many, many speakers? If it is, how many? Who tells you that? How do you determine that? So these are all open questions, right? And many times this corpus that you see won't really tell you all of this. And there are practical reasons why that is not always possible. You may want from 50 people, but it may not be possible from 50 people. And then, of course, after the recording, can we figure out automatically problematic recordings and remove them? And there will be a huge corpus, suppose 1,000 hours, 2,000 hours. It's not an easy task. So those are all questions that remains to be answered to create a good corpus for ASR. Okay, so with that, I'll move on and go to the TTS. So here is the TTS, we already know. So there are varieties of text to speech, right? It's not just we have single speaker TTS, meaning we want to build a program which mimic only one speaker, for which we need a lot of data from a single speaker. There are many approaches like multi-speaker TTS and so on. So now, but in this talk, we'll talk about only single speaker TTS. Right? So now let me give you some examples. Here are two TTS with which has been trained with almost state-of-the-art, like WebNet and Neural TTS, on two different data sets, both in English, of same size almost, 20 to 25 hours. And what I have done here, I have given various sentences, and we'll hear how the TTS does in terms of their quality or performance, right? You can tell a MOS right away. So this is the sentence on the left, and I'll play the TTSX.
Another plus for a good vocabulary is that on encountering uncommon words while reading, you are less likely to need to stop to look it up.
Can one of you confirm you can hear this?
Yes, sir.
Great. I'll go to the other TTS. Oops. 1 second.
Another plus for a good vocabulary is that on encountering uncommon words while reading, you're less likely to need to stop to look it up.
So you see, you understand these are synthesized, not a human speaking. But now I'll play you a very funny one that my student created. Sorry.
I am a first-year DIG scholar in the Department of Electrical Engineering at the Indian Institute of Science, Bangalore. I belong to SPIRE Lab, headed by Dr. Prasanta Kumar Ghosh. My research interests include physiological signal processing and machine learning.
I'll play the other
I
one.
am a first-year PhD scholar in the Department of Electrical Engineering at the Indian Institute of Science, Bangalore. I belong to SPIRE Lab, headed by Dr. Prasanta Kumar Ghosh. My research interests include physiological signal processing and machine learning.
Now you can see the obvious problems, right? The first one was giving wrong pauses. It could not read PhD well, and it was reading my name very weirdly. Was okay except the last name. But the second one was good actually, right, from the very beginning. But of course, it was a US data, US speakers data. The naming of the Indian names was not spoken correctly. So you can understand that although both of these are built with the same amount of data, but the data really matter. And almost good, I mean, it's not identical model, but almost state-of-the-art models. So data matters. And in fact, the last one will be even
Peter Piper picked a pack of pickled peppers. How many pickled peppers did Peter Piper pick?
so you see the papers are spoken as peppers. It's the Indian TTS.
Peter Piper picked a bag of pickled peppers. How many pickled peppers did Peter Piper pick?
Well, so it comes as paper, but not as pepper, but still there is some, tremor in the whole voice. Right? So now what happens is a notion, it has become a notion that we have to do a good quality speech, synthesized speech, we need to do a better modeling and for a given data set size. And then say, okay, no, we have to do a better job. We have to have more complex model and we need more data. But more data is more expensive and tiring for the speaker also. You can't go and collect 100 hours of recording from one person. In fact, the last speaker, as she was mentioning, right, that the sentences are carefully chosen. And this carefully, there should be some criteria for being careful, right? That is what we need to know more about. And I'll tell you some soon. Now, I'd like to highlight why this, the data about the data size. So the data size now has have been keeping growing. So this is a paper from for Melgan. They used 40 hours. This is a GAN TTS. They used 44 hours. There's a WebNet. They used 65 hours. So things are really, really growing. Question is, should we really need those? And more importantly, how long you can really record from an individual, right? 65 hours from an individual is not an easy task. In fact, over the time they speak, their consistency of the voice will go down. Then the question comes, okay, is there a criteria to design text? Exactly referring to the previous speakers, right? And then the data sets, so the data sets will depend on the language. If the language is very complex in terms of the acoustic structure, maybe you need more data. But if the language is not, maybe you need less data. And then whether there is any model complexity and training data size trade-off. Is it really that a complex model will do really good job always with more data? Can there be the case that a less complex model with not so much data will do equally good job? These questions are all really not answered today. And people are working, we're also working here to answer some of them. But I'd like to tell you what all really are happening to give a glimpse of those. Before that, let us see what database really exists today. Right? And for TTS is much less than ASR. For English corpora, there are quite a few: LJ Speech, CMU Arctic, AI Labs, then Blizzard Challenge corpus, and so on and so forth. There are quite a few again for Indian language corpus that again they are spread around. They're not in some central place that you can go and download, and some of them are not really released, but they are there. So people are also working to consciously to develop more corpus in Indian languages. But now I'd like to highlight, given that there are already some corpus and you know how the data and the choice of the data all of that really matters in the final performance. I'd like to tell you a similar kind of work that is happening, just like ASR, in the TTS area. So most of these works, you'll see that their claim is when you use this whole data set, it becomes, or it results in a poor performing system compared to if you select a few sentences and build the system. So for example, here, they say that paper, we show that a model trained on a carefully chosen subset of speakers from the lived speech TTS provides better quality of synthetic speech, right? And this is something that is repeated in many of these works that I'm going to show you now. And here also they show that, you know, the aim is to select utterances from the corpus which will produce most natural sounding voices. A similar one here for natural sounding voices. Many of these works are by the Julius group at Columbia together with Google. And again, same thing. Can we identify best utterances for doing the multi-speaker training voices? Here, a similar one saying that can we really detect and reject segment which can degrade the performance of the system? So it simply means that just collecting a lot of data is not good for building a TTS system. We may have to throw away post-recording. How do you identify those bad recordings and throw? So those are all open questions. And so on. So I'll not really repeat them, but I'd like to quickly go forward and then still leave these questions which are not answered. Of course, the optimal design of sentence to begin with, right? We don't really want to collect a lot of sentences because that will be anyway tiring for the speaker, may lose consistency, the voice quality and characteristics. So can you design sentences well or optimally and then use that for recording, right? So should we record more and prune? Is that a right approach, or record less with the right set of sentences? Correct approach, right? And more importantly, is when suppose if we have a domain of interest, suppose we want to do TTS in agriculture. Do you think if we already have a TTS in audiobooks or the corpus in audiobooks, will that be good enough for building or synthesizing speech in agriculture? If not, why? And what if you have to really build a TTS in agriculture? What sentences should we really train? Will it be in agriculture or it can be anywhere else? So these questions are still to be answered. With that, I'll move on for the interest of time. I'll just briefly mention about some initiative that we have been taking at SPIRE Lab. We have a project now supported by Bill and Melinda Gates Foundation, where we are working to develop resources, a data set in Indian languages for speech recognition in agriculture and finance. Similarly, there is another large-scale effort in India languages, TTS corpus creation. This is supported by ZIZ from Germany. In both these projects, these are large projects, we are targeting 9 Indian languages, as you see them on the screen. And the target for the ASR part is that in the domain of agriculture and finance, we plan to collect 1,000 hours of speech in each of these 9 languages and build models, ASR model, and Dockerize them so that anybody can use the corpus and these models, and this will be all made free. On the TTS side, the domains are also having general and healthcare, and we'll be recording 40 hours of speech from 1 male, 1 female person from each of these 9 languages. And again, we plan to build models and make this data and the models freely available. There are opportunities available, so if you're interested to work on such problems, ASR or TTS, please do feel free to go to this link. The project is called RESPIN. You can search with RESPIN IISc, you'll get there, and you can apply for all these positions. With that, I'll stop without taking much more time. I think I took a lot of time, so I'll stop there, and if I have any question, I'll be happy to address them. Thank you.
Thank you, sir, for your valuable inputs. With that, we have reached the end of the morning session. We are really grateful to all the speakers for an informative and lively session.